All right, so we are now on day 3, Thursday, April 30th, and this time around we are going to continue to solve quadratic equations, but we are going to mix it up a little bit, and that we're going to find the most efficient method that we can to solve these. So our agenda is to go ahead and do our classwork together, finding or using the most efficient method to solve quadratic equations. You will have a little bit of independent work, and then you will complete your exit ticket on Google Classroom. So the different strategies that we could use to solve quadratic equations involve our tables. We could set up a table of x and y values. We could sort of use the square root way, which is, completing the square or finding a way to complete the square and then finding the square root to find the x values. We could factor a quadratic equation, as we've done before. We started off this unit by factoring. We now know the quadratic formula, so we could apply the quadratic formula, or we could graph the equation. So we want, of these, let's say, 5 strategies, we want to figure out which one would be the most efficient. That means the one that involves the least work, in a way, or the easiest way to find our solutions, our x values. Well, right away, I'm going to start by eliminating some that I know will not be easy, or not the most efficient, rather. I'm going to eliminate the quadratic formula. And the reason why I want to eliminate the quadratic formula off the bat is that we've already talked about how the quadratic formula is really easy and helpful when we have a formula or the equation written in standard form, because we just simply plug in our A, our B, and our C within the formula, and then we can go ahead and find the solutions. Here, this is written in vertex form, right? In order for me to get it into standard form, that in itself would be an additional step, which is not really efficient. So I know that the quadratic formula would not be the most efficient method. Let's look at graphing. Well, it's in vertex form, so I know the vertex is 5, -16. And if I were to start by graphing that, and of course this is not anywhere going to be correct as far as proportion, and let's say this is -16, and this is my vertex, that tells me, the line of symmetry, but I would still have to find my y-intercept, right? And I would have to still find my x-intercepts. So is this the most efficient method, the graphing, when I have my vertex this far along down? I don't know, not so much. It could be, but it's not it doesn't grab me as the easiest way to start off. So I'm going to eliminate that one as well. So let's look at the other options here. So we have factored. Well, I could factor it. Well, is this factorable? I would again have to rewrite this in standard form in order to figure out my factors, right? Because we've been factoring it when it is in the standard form. So I would sort of identify the square root method, or finding the square roots, as the most efficient way. And this is why. First, I want to start by bringing my 16 over to the other side of the equal sign. And to do that, I am going to apply the additive inverse. I'm going to add 16 to both sides. So now I have positive 16 is equal to x minus 5 squared. So as we've done before, we know that we have to take the square root of both sides. And in this situation, I have 2 values. I have -4 times -4, which would give me a positive 16. And I have a +4 times a +4, which would also give me a positive 16. So I have a plus or minus that of the square root of 16 that I would have to take account in, right? There's 2 values that would give me positive 16, a negative and a positive. Here, the square root is going to cancel out this square, so I have x minus 5. And I could rewrite that now as x minus 5 equals a positive, square root of 16 is 4, and x minus 5 equals a negative square root of 16, which is a -4. Then I simply add 5 to both sides to get the x by itself. X is going to equal 9, and x is going to equal on this side 1. So I've identified the two values. In fact, I'm going to list them here, or the two solutions rather. X is equal to 9 and X is equal to 1. And we noticed that this was the most efficient way to do that, right? The quadratic formula, we could have done it. It would have taken an extra step. Graphing, no. Factoring. And the table too would have worked, but it just would have been a little extra work. Let's see here. Keep it moving. All right. So now we have another situation here. So in this one, I want us to try a couple things. We are going to start with find the square roots. And then we're also going to use a quadratic formula. And I want you to figure out which one would you do first. Which one is the most easiest way to do it? So, well, let's start by, if I'm going to start with the quadratic formula. Let's see, where did I bring that? Do I have it here? I should. Yeah, here we go. So if I'm going to start with my quadratic formula, I am going to subtract 2 to both sides because I want my equation to equal 0, right? So 3x squared minus 9 equals 0. So I want to identify what my A, B, and C are. I have A equals 3, positive 3. I have B, well, there is no B, so that is 0. And I have a C equals a negative 9. So now I'm going to put that into my equation. And right now, is this the most effective way? Well, we don't know yet. So we have X equals B, well, 0. Doesn't matter if it's negative or positive. Plus or minus 0 squared minus 4 times 3 times negative 9 all over 2 times 3. So now I'm going to have the square root of 4 times 3 is negative 4 times 3 is 12, negative 12 times the negative 9 equals 108. And I have that all over 6. So now I want to go ahead and figure out what the next step is. 108 is not a perfect square, right? 100 is, but 108 isn't. So what I could do now is I could go ahead and put that in my calculator. 108, take the square root of 108. And I'm going to just take the first several digits, the whole number and the first digits after the decimal, 3, 9, and 2, and I divide that by 6. And again, this is a plus or, yep, this is a plus or minus. Yep, plus or minus here. So I have a positive 10.396 or I have a negative 10.392 over 6. So if I want to go ahead and do the next step, divide that by 6, I have 1.732. So x can equal 1.732, or x could equal positive or negative 1.732. Right, so we just used the quadratic formula to solve this. Now, was it the most effective way? We're not sure. So let's go back and see if we can do this another way. So I'm going to now apply the square root method. And to do that, I'm going to add 7 on both sides. And I have 3x squared equals 9. And now I'm going to divide both of these by 3 because they're both divisible by 3. 9 and 3 are. So I have x squared equals 3. And now I want to take the square root of both x squared and 3. So here I'm going to have x is equal to, well, it's a positive and a negative value. That's going to give me 3. And again, I can just take out my calculator and I'm going to do this I have square root of 3 is 1.732. So x is equal to the negative 1.732, and also x is equal to a positive 1.732. So according to, well, at least for me, I believe the square root was a little bit more efficient, right, than the quadratic formula. First of all, it wasn't completely in standard form to begin with. We had to write it in standard form. It didn't have a b term, which isn't horrible, but it just wasn't necessary. If it doesn't have a b term, then, why do it unless the other ways don't work? And so this might have been an easier way, the more efficient way to do this one. So now we're going to try, let's see if we could do one more before we run out of time. Actually, let's try this one. All right, so would a table work for this one? Yeah, we could easily set up a table. But again, I sort of refer to the table if that's sort of a last resort, unless it seems really easier for us to do that. We will do one with a table, but I want us to try a different method here because I noticed right away that this is actually easily factorable. If I do 18, right, negative 18, right, so I know this is going to be a negative, and a negative 3. So if I list the factors of 18, well, 1 times 18, right, 2 times 9, 6 times 3. This has to be negative, and this also has to be negative. So, well, which one, if I add up any of these, which one would give me 3? Well, this wouldn't work either way. This wouldn't work. I would have a negative 7 or a positive 7. But here, if I have negative 6 plus 3, I would indeed get a negative 3. So while this is in standard form, we didn't use the quadratic formula because this was an easier way for us to approach this just by factoring it. So I have x minus 6 and x plus 3 equals 0. And so our solutions are x minus 6 equals 0, so x is going to equal positive 6, and x plus 3 equals 0, so x is going to equal a negative 3. And so again, that gives us our two solutions, right? And this was obviously an easier way for us to approach this one. All right, and now let's see. Now we want to try another method. So for this one, we're going to go ahead and try, can we factor this? Well, we might be able to factor it. 2 times 28. Let's see, what is 2 times a negative 28? Gives me a negative 56. And I also want some x, my b term, to be 1, positive 1. So what would give me a negative 56, but also add up to 1? Oh, I knew it was close. 8 times 7. So 8 times 7 multiplied to give you 56, and one of them has to be negative to get a negative, but it also has to add up to positive. So I want the lower term to be the negative. So negative 7 plus 8 does in fact give me 1. And so if I were to go ahead and factor this, remember I bring down the 2x on both sides. And now I have negative 7 plus 8. And now lastly, I want to take out my trash. So I have 2x minus 7 because they don't share greater common factor, but this one does. I can factor out 2 from both of these, and I'm left with x plus 4 equals 0. Now again, I still haven't solved for x, right? So that's another step. So x minus 7 equals 0. I have to add 7 to both sides. And then 2x. And so now I have 2x equals 7 divided by 2. And I know I'm moving fast because I'm fighting against the clock, but you can always sort of slow it down. And I'll just leave this in factored form. Here I have x plus 4 equals 0. And now I just want to subtract 4 on both sides. So x equals 4. So this could have been the most efficient way, right? It was definitely factorable. Or we could have tried, perhaps, I notice I have a dilation of 2 because we haven't really used graphing. Or maybe a table might have been a quicker way to do that. All right. So this lesson sort of gives you a heads up to what, what I'm going to be expecting when we do have a formative, because we will be another formative rather, because we will be looking at the most efficient method to solve a quadratic.